Swayam Prabha. Digital India. Educated India.
Welcome once again to our discussion on dummy variable models. Basically, we were discussing about the applications of dummy variable models, right? So, in our last class, if you recall, then what we were doing, we were trying to understand uh, basically whether a dummy variable model can be applied in a context where our variables where firstly we discussed about the saving income relationship, and then later on we talked about how to use that saving income relationship in a dummy variable context. That means to test the structural break, how the dummy variable model can be an alternative of the chow test that we learned earlier, right? And we discussed that uh, dummy variable model can actually overcome the several limitations of the chow test model. Today again we'll discuss another application of dummy variable model, and this application is uh, basically to test whether there is any seasonal fluctuation in a time series data. Okay, so dummy variable model for testing seasonal fluctuation. So I will write dummy variable model for testing seasonal fluctuation. Seasonal fluctuation. Okay, seasonal fluctuation. Now, many times what do we see that that the time series variable, they give some kind of fluctuation uh, based on which particular season we are observing that particular variable. For example, if you think about the sales data, let's say we have sales data on a refrigerator. Okay, sales data on refrigerator and other household appliances, let's say washing machine, dishwasher, then a refrigerator, so on and so forth. And many a times what we observe that the sales of these household appliances, they do show some kind of seasonal fluctuation. For example, sales of refrigerator will be quite high in uh, during the summer season and quite low in winter. Similarly, the home appliances like uh, mm, uh, washing machine, TV, so on and so forth, you may be seeing that the sales of these appliances are quite large during the their Diwali season. So if you have, let's say, quarterly data, right? That means in a year, basically you have 4 quarters, and your objective here is to see which particular quarter in a year, gives you the significant sale, right? Whether all the quarters sales in all the quarters are significant, or it is happening in some of the quarters, and based on that, as a salesman, as a salesperson, you may devise some kind of policies. Okay, that is our objective. So we have data on sales for these household appliances, okay, household appliances, and you want to see whether sales in a particular quarter is significant, right? Now why do we do so? This is very important for time series data. For example, here if you look at the sales, basically sales is actually a function of sales is a function of, let's say, alpha plus beta 1 is the expenditure on durables, okay, expenditure on durables. Let's say this is my durable expenditure plus this is, let's say, TUT. Okay, this is sales, which is sales on appliances, household appliances, which is a function of the expenditure on durables. And if you try to run this type of regression, then what will happen? Firstly, what you need to do, you need to remove some kind of seasonal fluctuations from this data. Why this is so? Because a time series, please remember, a time series data T is actually a summation of three type of fluctuation. What are those? Firstly, a time series data will show you some kind of seasonal fluctuation. So let's say that is called S, seasonal. Then second is cyclical. Then third is T, and the fourth is the random one. Okay, so this is seasonal. This is cyclical. Then this is trend. Any time series data will show you some kind of trend over a period of time, and this is purely random. Okay, purely random. Now this random component, what you are already adding in the model, you see there is UT, but S, C and T, this seasonal, cyclical and trend, this variable should be removed from the time series variables, for example here sales or durable expenditure. Otherwise, you may get a spurious regression in time series data. Okay, a spurious regression. And there are specific ways by which you can remove the cyclical and the trend component of the time series. In this example, we are basically interested in how to remove the seasonal component from the time series data. Seasonal component, right? So if you do so, sales is a function of durable expenditure. That means to remove the seasonal component from the data, what we need to consider that these 4 quarters are actually different. 4 quarters are actually different, and that is why while modeling we need to accommodate the fact that these quarters are actually different. If you do not consider that fact, then your model will suffer from the seasonal fluctuation. Okay, seasonal fluctuation. So what we need to do here? Here, let us say for the time being, I am removing the durable expenditure part, this variable. So we will start our analysis with a simple ANOVA model. Simple ANOVA model. So as you know that ANOVA model will not consider any quantitative covariate as explanatory variable. So in that, sales is a function of, let's say, you have 4 quarters, then you have alpha plus, let's say, beta 2 d 2i plus beta 3 d3i plus beta 4 d4i plus ui. Okay, ui. And how we have defined d2, d3 and d4? So d2 I equals to 1 if second quarter, zero otherwise, d3i equals to 1 if third quarter, zero otherwise, and d4i equals to 1 if fourth quarter, zero otherwise. Okay, zero otherwise. This is how we have defined the dummy. And we have not defined what is our base category here, since we have not assigned any dummy for the first quarter. That means D1I is a base category. D1I is, that means the first quarter is the base category. So that means all these beta 2, beta 3 and beta 4, they are differential intercept. You all know differential intercept. So that means they will basically tell you that whether the sales in second quarter is significantly different from first quarter. D3 will tell whether the sales in the third quarter is significantly different from the first quarter, and D4 will be beta 4 will tell whether the sales in fourth quarter is significantly different from the first quarter. But see, our objective initially, when we posed the problem, our objective was not to examine whether sales in a particular quarter is different from any of the other quarters with the base quarter, which is first quarter here. Rather, we are interested in, out of these four quarters, which particular quarter gives you a significantly higher sale. It might be second quarter, third quarter, fourth quarter, first quarter, or all the quarters together. Are you getting my problem? Our initial research question was whether the sales in refrigerator or likewise any other household appliances, sales in household appliances are significant in all the quarters or in one or two quarters. So basically, we were interested in only seasonal presence of seasonal fluctuation on the sales of the durables, right? That is our objective. If that is the case, if you set this type of model, dummy variable model, then your objective is not fulfilled, because in this model they will only tell you whether the sales in a particular quarter is different from the base quarter. So what is this model tell you? This model's objective is whether sales in a particular quarter is significantly different from the base quarter which is which is the first quarter here. But our initial objective, what was our initial objective? Our initial objective was to see whether sales are significant in all the quarters or not. All the quarters or not. So we are not interested in checking the significance of sales in a particular quarter with the base. Now, if this is your objective, then you cannot set this type of model. So what type of model then you have to set? You have to basically set this type of model. Sales equals to alpha plus beta 1 d1i plus beta 2 d2i plus beta 3 d3i plus beta 4 d4i plus ui. Okay, and now beta d2, d3, d4 we have already defined, and d1i is now equals to 1 if first quarter 0 otherwise. 0 otherwise. So this model should be specified. But if you specify this model, what would be the problem in estimation? What would be the problem in estimation? Can you think of? If I said this type of model, what would be our problem in estimation? The problem is, see, here we have assigned, four dummies to represent 4 quarters. But what is the rule says? The rule says that there should be n minus 1 dummy. That means if you have n categories, category means here it's a 4 categories, 4 quarters. So you should have introduced 4 minus 1, 3 dummies. Now our problem is, if we assign 3 dummies, then that model will tell you what would be the interpretation of the dummy variable coefficient. They will only tell you whether sales in a particular quarter is significantly different from base quarter. So that can't serve our initial purpose. And if we fit this model to serve our initial purpose, that means to see whether sales in all the quarters are significant, then we will end up with dummy variable trap. Dummy variable trap. Okay. Now, what is the exact problem of dummy variable trap? That first we will try to understand using the data. So look at the data set. This is our data. So we have quarterly data. So in each year we have 4 data points, right? 4 data points. And look at, see here, this means dishwasher sale 841, all in thousands. This data is also taken from the United States, and this is taken from your textbook Gujarati, that basic econometrics textbook, and this is table number 9.3. Okay, this data is from table 9.3. So this is the sales data of refrigerator, which is represented FRIZ, and then this is washing machine, and this is actually the quantitative covariate, which shows the total expenditure on the durables. And then what we did, we have introduced 4 dummies. So this data is from first quarter, that is why D1 equals to 1, and see all other quarters are 0, D2, D3, D4 are 0. Similarly, the second data point is from the second quarter, that's why first, third and fourth quarter dummies are 0. This data is from the third quarter, that's why first, second and fourth quarter they take the value 0. And similarly, the dummy for the fourth quarter is 1, and that's why first, second and third quarters take the value 0. So here we have assigned 4 dummies for 4 quarters. And let us see, if we do so, that means if we violate the rule of assigning dummy, what type of estimation problem we may end up due to dummy variable trap. Let us see. We'll try to estimate. Okay. So what we'll do, we will regress let's say fridge means sales in refrigerator, which is a function of D1, D2, D3 and D4. Okay, D1, D2, D3 and D4. 4 dummies we have introduced and then enter. Okay, now look at this. Stata has reported that D4 omitted because of collinearity, and here also in the output set we see the coefficient corresponding to D4 is 0 and it is written in the bracket omitted. Okay, omitted. Now what is the problem? That means we have assigned 4 dummies, but while reporting the result, Stata is basically omitting 1 dummy. Here they have omitted the 4th dummies. Okay, now why Stata is dropping 1 dummy? That means, is there any problem in estimation if we introduce 4 dummies for 4 quarters? To understand that, we have to once again go back to the way we have represented our multiple linear regression model using that matrix algebra. That will make things clear. So you will know what exactly is the problem of dummy variable trap. So for that, we will go back to our model, right? So let us say that this was yi equals to alpha plus beta 1 x1i plus beta 2 x2i plus beta k x ki plus ui, and where I is basically equals to 1 to n. So that means this equation is for ith individual. I is indexed for individual. Okay, I is indexed for individual. I is indexed for individual. Okay, individual. So what will happen? You will see y1, if I substitute the values of I for 1, 2, 3, n, what will happen? This would become alpha plus beta 1 x11 plus beta 2, then you will get x21 plus beta 3 x31 plus dot dot beta k x k1 plus u1. Similarly, y2 would be alpha plus beta 1, then x12 plus beta 2, x22 plus beta 3, x32 plus beta k x k2 plus u2. Okay, this will happen. So that means ultimately you will have, if you represent this, what will happen? Y in would become alpha plus beta 2 x1 in plus beta, sorry, this is beta 1. This is beta 1. So this is beta 1. Beta 1 x1n plus beta 2 x2n plus beta 3 x3n plus beta k xkn plus un for the nth. Okay, so that means you will represent this equation as yn. Sorry. So in matrix notation, how we represented this? We represented as y1, y2, dot 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 yn equals to what we did. So we'll take this alpha as common. So this will become 1, 1, 1, 1, and then we'll have x 1, x 2, x 3, and then xk1. Then you have x12 dot dot x1n x21. Sorry, this is x22, x22, then x2n, then x32, then you have x3n, then xk2, then xkn, and here you will have alpha and then beta 1, beta 2, dot 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 beta k. Okay, beta k plus you have u1, u2, u3, dot 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 u. So this we have discussed.